Alright, today we are going to discuss properties of logarithms. I'm going to go in more depth with properties of logarithms than we did in the last video. So the first thing we're going to look at is this change of base formula. Now, we're going to start this out by saying we're going to let a, b, and x be positive real numbers such that a does not equal 1 and b does not equal 1. Then we can say that the log with a base of a of x can be written with a different base as follows. If we want to use base b, we can write it as log base b of x over log base b of a. If we want to use the common log with a base of 10, we can write this as the log of x over the log of a. Or if we want to use a base e, then we can write this as the natural log of x over the natural log of a. So let's look at some examples. In example 1, we're going to ask ourselves, what is the value of the log with a base of 4 of 24? What does that equal? So we're going to use the change of base, and I like using the common log, so that's what I'm going to do in this example. We're going to write this as the log of 24 divided by the log of 4, and then we're just going to use our calculator to calculate what is the log of 24. That's 1.39794 divided by the log of 4 is about 0.60206, and if we divide those two numbers, we're going to get that our answer is about 2.3219, and that's going to be our answer. We're going to do the same thing, use the same log in example 2, but this time I'm going to use the natural log. We're going to use a base e. So we can write this as the natural log of 24 over the natural log of 4. In fact, before I write that, we're still doing log with a base of 4 of 24. Which, if we look at the natural log of 24, that's about 3.21888. And the natural log of 4 is about 1.38629. Just use a calculator to calculate that. If we divide that, we're going to get about 2.3219. So it does not matter what base we use. If we're going to use this change of base formula, we should get the same answer. So now I'm going to go over some properties of logs. And these properties of logarithms also work for natural logarithms. So before I write any stuff, we're going to first write a little statement. We're going to say let a be a positive number such that a does not equal 1. And we're going to let n be a real number and let u and v be positive real numbers. Then we can start looking at some properties. So there's 3 properties that we're going to write down right now. We've got the product property, we've got the quotient property, and lastly we've got the power property. So we're going to look at this with 2 different types of bases. The first one is going to be a log with base a. And then the other one we're going to look at is the natural log. So if we're looking at the product property of a log with base a, we're looking at if we have the log base a of u times v. That's going to equal the log of base a of u, and I'm going to actually erase this natural log wording right here for now, plus the log the base a of v. So we can rewrite it that way. With the quotient property, if we have the log of base a of u divided by v, we can write this as the log with base a of u minus the log with base a of v. And the power property says if we have the log with a base a of u to the power of n, that's the same as n times the log with a base a of u. Now for the natural log, all we would really do, I'm going to put a little divider, natural log, we replace the word log with ln. Natural log of u times v is the natural log of u plus the natural log of v. The natural log of u divided by v is the natural log of u minus the natural log of v. And the natural log of u to the power of n is n times the natural log of u. Not too bad. Let's look at an example. So example 3, we're going to evaluate the log base 5 of the cube root of 5. Now, think back to your early algebra days. We can rewrite the cube root of 5 with a rational exponent. So we can write this as log base 5 of 5 to the power of 1/3. Then we can use that power property we just looked at and rewrite this as 1/3 log base 5 of 5. And from what we learned in the last video, if the base and this number match, that means it's 1. So we have 1/3 times 1, so our answer is going to just be 1/3. Let's look at a couple more examples where we're going to utilize these properties. So in example 4, all we're going to do is expand this logarithm out. So we have we're going to have log base 4 of 5x cubed y. So this is first a product of 3 different terms. So we can rewrite this as log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Now in this middle term, we've also got a power. So we're going to bring the 3 down. We're going to rewrite this as log base 4 of 5 plus 3 log base 4 of x plus the log base 4 of y. And we've expanded it, so we are done with that. Let's look at one more. For b, we're going to look at the natural log of the square root of 3x minus 5 over 7. So first, this is a quotient. We can write this as the natural log of the square root of 3x minus 5 minus the natural log of 7. And we can rewrite that square root as a power that is a fraction. So we can rewrite this as the natural log of 3x minus 5 in parentheses to the power of 1/2 minus the natural log of 7. Now, power rule, we can bring the power of 1/2 down. So we can write this as 1/2 times the natural log of 3x minus 5 minus the natural log of 7. And we are all done. We've expanded it out. There's no other property we need to utilize. I do have one more type of example. This is example 5. We are going to condense down to a single log. So we're going to first look at having 1/2 times the log of x plus 3 times the log of x plus 1. And we are going to condense that down to one expression. Now we can, using the power property, rewrite this as log of x to the 1/2 plus log of x plus 1 to the 3rd power. And then, since that's a x to the 1/2, we can write that as log of the square root of x plus log of x plus 1 cubed. And if we look at the product property, we can rewrite this as the log of the square root of x times x plus 1 cubed. And we've condensed it down to one expression. Let's look at a couple more examples. We're going to do a 5b and a 5c, just to really get the hang of it. We're going to look at 2 natural log of x plus 2 minus the natural log of x. So first, utilizing the power property, we can rewrite this as the natural log of x plus 2 squared minus the natural log of x. And then we can utilize the quotient property to rewrite this as the natural log of x plus 2 squared divided by x. And we've condensed it down to one expression. Let's do one more example and then we can call this lesson good. So example 5c, we're still going to condense this down. We're going to look at 1/3 times the log with the base of 2 of x plus the log base 2 of x plus 1. And we're going to rewrite this. So first, I look at what's in the brackets, the log portion, and I can see I can rewrite that using the the product property. So we're going to have 1/3 times the log with a base 2 of x times x plus 1. Now I've got this 1/3 out in the front. We can take care of that with the power rule and write it as log base 2 of x times x plus 1 to the 1/3 power. And since we know a power of 1/3 is the same as a cube root, we can write this as the log the base of 2 of the cube root of x times x plus 1. We've condensed it down to one expression, and we are done. And we're done with this video. This whole lesson, we are done.